point here is that in the human dimension, you can do all the sortie missions you want. And as long as they're 2 weeks, a month, maybe 2 months, you can do all those you want, no problem. But as soon as you start doing long duration, and when you go long distances, you have to go longer duration, you have problems. And the biggest problems, of course, are radiation and hypogravity. So, ladies and gentlemen, I'm sorry to say this to you, but if you still think that astronauts are going to wake up on the surface of the moon and Mars, drink their Tang, have their breakfast, climb into their spacesuit, grab their pick and shovel, and it's out of the airlock for 6 to 8 hours of work on the lunar surface or the Mars surface, I have bad news for you. In my opinion, it ain't gonna happen. And radiation is the reason. It's not because I'm trying to be a spoilsport. All those nice, pretty, shiny aluminum cylinders you see in the PowerPoint presentations on the surface of the moon or Mars, ladies and gentlemen, that is strictly propaganda. That means we're going to have robotic precursor missions to scout destinations and prepare the sites for human presence. When the robots do everything, and when the humans arrive, the robots hand the keys to the front door to the astronauts who exit the vehicle and go into the radiation-protected and/or subterranean chamber. So here's what we're going to have to do. We're going to have to go to the asteroids. We're going to have to burrow in, core out part of the asteroid, process the material, use that material to build our habitats, fairly large-scale habitats that rotate to create gravity. The way to explore Mars is to do it with forward-deployed human beings on Deimos. Here are some of the virtues of Deimos. If you consider Deimos a near-Earth asteroid, a near-Earth object, even though it technically really doesn't meet that definition, it's the third largest when you look at it in asteroids that are from the orbit of Venus to the orbit of Mars. It has a mean diameter of 12.6 kilometers. It has a low delta V, a lower delta V than either the Moon, Phobos, or Eros. And look at this. Escape velocity from Deimos is a whopping 12.5 miles an hour. So let me show you the shape of things to come. And that is, if you are going to do an interplanetary vehicle and you're going to put humans inside, it's going to have to look something like this. Now, does this look familiar to anybody? What is it? No, it's not the Death Star. No, it's not the Death Star because we won't be sending anything that big. That's right. It's the Discovery vehicle from 2001.